Problem number 21. For the network shown below, determine all the branch currents. So this is the network. So we have to find the branch current, that is branch current of BA, branch current of AC, branch current of CB, BO, AO, CO. So before that, we will indicate the currents using Kirchhoff first law of the junction. So let us name the current from CB as I1, and it is divided, and the branch current BO is I2 and branch current BA is I1 minus I2, branch current AC is I1 minus I2 minus I3, branch current AO is I3, branch current OC is I2 plus I3. So this we have done applying Kirchhoff first law to all the junctions. So now we will use the Kirchhoff second law, that is voltage law, and use law to the loops. So there are three loops, that is BOC, BAO and AOC. So we will use the Kirchhoff second law. So first we will take BOA loop. So from the circuit we can say that minus I1 minus I2 minus I2 I3 plus 4I2 is equal to 0. If simplify this is what we get, equation 1. So this is equation 1. And for the loop AOC, if we simplify, this is what we get, the second equation. And for the third loop, that is COV, when we simplify we will get the third equation. So using this equation we will simplify further. So first we will multiply 2 to the equation 1. So when we multiply, it will be almost similar to equation 3. So using that we will add the both equation and we will get a fourth equation, that is 10I2 plus I3 is equal to 5. Then again we will multiply 2 to the equation number 2. So this is equation number 2, we will multiply, and 1.5 to the equation number 3. So when it will be similar, and we will start adding those two equations to further simplify, and we will get this equation 30I2 28I3 is equal to 15. Then we will multiply again 3 to the equation 4, which will be similar to the equation above, and if we subtract the both equation, we come to know that I3 is 0. So therefore the branch current of AO, so branch current AO, that is I3, will be 0 amps. So using that we will simplify this in one of the equation and we will find I2. Then the I2 will be of 0.5 amps. Then further we know that I2 and I3 will further simplify in one equation and we will find out I1. So once we find out all the three, we will simplify or equate in all the branch current equation and find the branch current. So we know that CB is I1, which is nothing but 2.5 amps. Next BO is I2, which is nothing but 0.5 amps. Next is BA is I1 minus I2, that is 2.5 minus 0.5 is nothing but 2 amps. Next AO is, we know that I3 is 0, therefore the branch current will be 0. Next is AC branch current, that is I1 minus I2 minus I3. This will be 2.5 minus 0.5 minus 0, that will be equal to 2 amps. Next OC will be I2 plus I3, that is nothing but 0.5 plus 0, that is 0.5 amps. This is how we find the branch current of this given figure. Problem number 22. Find the value of R and the current flowing through it in the circuit given below when the current in the branch OA is 0. So first we need to find R. So R value, that is a branch current of CO, and next we have to find the current flowing through it. So from the figure we can see that the current flowing through R is nothing but I2. So we have to find this two, R and I2. So they also given that the branch current of OA is 0. So there is no current flowing here. So first we will indicate that the branch current of BA is I1 and BO is I2. So then we will use Kirchhoff first law, that is current law. Applying this law to the junctions of B, A, O, we will write the current flowing. So from CB the current is I1 plus I2. It will split to I1 in branch BA, I2 to branch BO. As there is no current flowing from A to O, the I1 will flow to branch AC, and again O to C will be I2, and the summation to branch C and B. So this using applying Kirchhoff first law to all the nodes. Then let's use the Kirchhoff second law for all the loops, that is the voltage law. First we will take this loop and write the equation, that is minus 4i plus 0. As the branch current is 0, the voltage drop will also be 0, plus as the current is opposing, it will be plus 1 into I2. Further simplifying, we will get equation 1, that is I2 is equal to 4 times I1. Next we will write the second loop, Kirchhoff voltage second loop, that is minus 1.5 I1 plus, as it is opposing, we will write plus R I2. So is equal to 0. So we got two equations, equation 1 and equation 2. So we will simplify this equation number 1 in equation 2. When we simplify equation number 1 in equation 2, this is what we get, and further simplification we will get R value. So R is nothing but 0.375 ohms. So we have found out R, the value of R, and we have to find the current flowing through that resistor. So next we have left one more loop. So we will also apply the Kirchhoff second law here. So when we apply minus 1.5 into I1 plus I2 plus 10 minus 1.1 I2 minus R I2 is equal to 0. So here we know the value of R I2. So this is the value of R and I2. So we will apply this in this equation, and further some simplification we will finally get I1 value. Once we get the I1 value, we will substitute in equation number 1. Once we substitute, that is nothing but I2 is nothing but 4 times I1. So we will multiply this into 4. We will get 3.1 amps. That is the final answer. So we got the value of R, and the current flowing through the resistor that is I2 is 3.1 amps. Problem number 23. In the network shown in figure 1.35, determine all branch currents and the voltage across 5 ohm resistance by mesh current method. So this is the figure. So we have to find the branch current, that is IA, IB and IC. So first we have to find IA, next is IB and IC, and next we also have to find the voltage across 5 ohm resistance. So this is the 5 ohm resistance. So let us call this voltage across 5 ohm as V5. So we have to find all this 4. So first let us apply the Kirchhoff voltage law to the mesh, both mesh. So let us let the loop currents be I1 and I2. So this is the loop. So this is another loop. When we apply Kirchhoff voltage law, we will get 50 minus 3 IA minus 5 IC minus 6 IA. So we will further simplify this, and we'll get one equation, that is nothing but 14 I1 minus I2. So we have taken the loop current, right? So this is nothing but we have to apply current, loop current. So when we apply loop current, 50 minus 3 I1 minus 5 I1 minus I2 minus 6 I1 is equal to 0. So once we simplify this, we will get the equation 1. And for the same thing, for the mesh BCDB, we will apply the Kirchhoff voltage law as a loop current I2. So we will get minus 2 I2 minus 8 I2 minus 5 into I2 minus I1 minus 25. So once we simplify this, we will get another equation, equation number 2. So solving equation 1 and 2, we will get I1 and I2. So once we get I1 and I2, we can easily find out IA, IB and IC. So as we know that IA is nothing but I1. So therefore IA is nothing but I1, which is nothing but 3.378 amps. And IB is nothing but minus I1. So minus I2. So minus I2 is minus minus plus. So IB is nothing but 0.54. So from the figure we can say IC is nothing but the addition of I1, IA and IB, that is nothing but 3.918 amps. So using, once we get IC, the voltage across V5 is nothing but V5 is equal to 5 into IC, that is nothing but 3.918 into 5. So V5 is equal to 19.59 volts. So nothing but 19.59 volts. So we have found out all the 4 values which are required. Problem number 24. A 250 volt lamp is rated to pass a current of 0.3 amps. Find its power output, that is nothing but P. Now if the second similar lamp is connected in parallel with the first lamp, find the supply current required to the given same power output in each lamp. So first we will write for the first thing, that is 250 volt lamp. So this is 250 volt lamp where the current is given as 0.3 amps. So we have to find out, that is V is equal to V into I, which is nothing but 75 watt. So this is nothing but 75 watt. So similarly, I will write 2 lamp which is in parallel. So this is one lamp. This is another lamp. This is the supply current, that is I1. So I will write the current here as, so they have said that similar lamp is connected in parallel with first lamp. Find the same power output. So if it has same power output, current should also be same. Voltage should also be same. So this is first lamp. So same power output is 75 watt. So if it's 75, voltage will also be 250. As it is in parallel, current will also be 3 amps. So this is second. So the supply current will be 0.6 amps. This is when the lamps are connected in parallel. The same problem, this is the 25th problem. Calculate the power if the lamps are connected in series. So lamps I'll indicate in resistor. So this is one lamp. So current is given as 3 amps. So voltage across it is equal to 250. So power is 75 watt. So what is the resistance value? So that we will find out using this equation, that is nothing but 833.3 ohms. So what if this has been connected, 2 lamps are connected in series with the same resistance, 833.3 ohms 833.3 ohms. So the voltage and current, so when the resistance are there, so when we add the equivalent resistance, we'll get 1666.60 ohms. When we simplify, we will get the current as 0.15 amps. Therefore the power will reduce to 37.5 watts. So as you can see, when the lamps are connected in series, the power dissipated from the lamp will be less, that is 37.5 watts.